Hi, I'm Ayariza, and I will be starting our presentation. So, our project focuses on forecasting retail sales. We use Dataset A. It covers a snapshot of 90 days from June up until August 2025. Our goal is really straightforward. It is to figure out exactly what drives revenue and use those insights to build a model that helps store managers make smarter decisions in the future. The main problem we are solving is unpredictability because daily sales fluctuate widely based on the day of the week, promotions, and even the weather. And currently, managers rely on their intuition to guess these numbers. And so this leads to many kinds of problems, and two of them are first of all, we have staffing error because managers either overstaff and they waste money or they understaff and they frustrate customers. So the second one is inventory mismanagement. Ordering too much stock causes waste, while ordering too little leads to stockouts. So in retail, the margin is really thin. Decisions need to be made in advance, and replacing this gut feeling with an accurate forecast is really critical to protect the profit. Now, why does this matter? This matters because daily revenue impacts almost every operational decision. Labor is one of the biggest expenses in retail. If managers get the forecast wrong on a slow day, that budget is gone. If they get it wrong on a busy day, they lose sales due to the long lines. So, by accurately predicting demand, we help the store optimize both their workforce and their inventory and to ensure there's a smoother experience for a customer and better bottom line results. Um, so let's go over the data that we used to solve this. So it covers 90 consecutive days of store operations, as I said, and the data is rich in operational features. So it tracks daily customer count, average transaction value, temperature, and promotion status. Now, in terms of data preparation, we focus on engineering features that would help a model learn time-based patterns. We clean the timeline, and most importantly, we created lag features. This means we fed the model data from the previous day and the previous week. So this is crucial because in retail, sales patterns tend to repeat weekly. And so yesterday's performance is often used to calculate or to predict today's performance. So to analyze this data and build our forecast, we selected four specific techniques. We have that descriptive analysis, which is to visualize high level weekly and monthly trends. We have multiple linear regression, and we chose this for mostly interpretability. It allows us to quantify exactly how much a specific driver, for example, promotion, how much it lifts the sales in dollars. Random forest, we use that um, to improve accuracy. Sales are really complex and non-linear, and so random forest is excellent in capturing interactions like weather impacts weekend traffic differently than weekday traffic. And lastly, we have time series analysis, which to account for seasonability and cycles. Now, in order to validate these models, we used a chronological split. So we did 70% days of training, and then we have 30 validation and testing, 15 each. And for our random forest model, we tuned two specific parameters. First, we set the number of trees for 1,000 because this makes the model more robust and less likely to fluctuate. And the second thing is we set the variables per split to three. And so um, this forces the model to consider a wider variety of predictors for each step rather than relying too heavily on just one dominant factor like customer count.
Hello, my name is Kirsten Babaji, and I will be going over the analysis and results. We analyzed 90 consecutive days, June through August 2025. Monthly revenue is flat within about 1%, so the meaningful movement happens inside each month. Weekends are the engine, about 45% higher than weekdays, with Sunday on top and Saturday next. Tuesday is the strongest weekday, and when you run a Tuesday promotion, it adds about 29% versus the non promo weekday average. This frames our strategy, staff to the weekly rhythm, place promos where they pay, and use a short 14-day forecast to set labor and orders. The weekly view shows clear peaks and dips inside each month. That is where scheduling wins or loses. The weekday chart ranks performance cleanly. Sunday and Saturday lead. Tuesday is the top weekday. Friday is the softest. The promotion chart focuses on Tuesday, where promos in this dataset drove the largest verified lift. These two plots help with hot weather playbooks. Traffic is normal to good from about 76 to 85 degrees. It softens after roughly 88 to 90. Revenue is steadier than traffic, but you will still see a small dip in the upper 80s to low 90s. From this analysis, we could implement processes such as cooling the store earlier on hot days, moving cold and quick items to end caps, and push curbside pickup in the morning message. Our test shows a clear winner. Linear regression is the most accurate model on both splits. On the validation window, its RMSE is 179.31. On the held out test window, it drops to 108.20. Random forest is much higher, 639.11 on validation and 396.14 on test. Linear regression reduces error by about 72% versus the random forest on both windows. The data set is short and the key drivers are linear: customers, weekend, average ticket, and Tuesday promotion. A simple, well specified linear model fits that story best. We will use linear regression for the daily 14-day plan. We will keep random forest as a diagnostic check, not as the primary forecaster. The top predictors were daily customers, weekend effects, average transaction value, and Tuesday promotions. The linear model quantifies lift in plain numbers. The forest confirms the same drivers and captures mild nonlinearities, like how temperature interacts with day type. This gives us both clarity and accuracy, which is what we need to run the operation week to week. For planning, we convert the forecast into three bands. High means add a shift, medium is the standard plan, low means remove the shift or move hours into the 11 a.m. to 3 p.m. window. This turns analytics into a one-page run sheet every Monday. It also reduces overtime on slow days and shortens lines on peak days. We use the descriptive views to set expectations and find operational patterns. We use linear regression when you need clear effect sizes, for example, weekend lift, promo lift, and how temperature relates to traffic. We use random forest when we want the best short term accuracy and check on interactions. We always compare to the weekly repeat baseline so we know the model is beating a simple rule we already understand.
Hi, I'm Christine Sanchez, and I'm going to go over the business impact and recommendations from our presentation. I will be going over the actionable business insights, the implementation recommendations, the expected business value, and the next steps for the business. With the actionable business insights, the customer traffic and average transaction drives majority of revenue. The strongest and most consistent finding from the data and graphs is the near linear relationship between the daily customers and daily revenue. This means every additional customer directly increases revenue in a predictable way. So the business impact on this is that strategies that boost foot traffic have the highest return of investment. With the average transaction, a moderate increase in average transaction size yields substantial revenue impact. So the impact on this business is that upselling and bundle strategies can significantly grow revenue. For promotions, this showed that there was an increase in revenue. So promotion days show noticeably higher revenue levels. The impact on the business, promotions reliably boost sales and are effective even when controlling for customer traffic and temperature. With higher temperature leads to more customer flow. So the temperature customer scatter plot shows a rising trend. This means that the store benefits from warm weather. Summer campaigns should be intensified on hotter days. For the implementation recommendations, I'm going to go over the increase for promotions on high temperature days and high traffic days. So this means that scheduling promotions should be during the weekends from Friday, Saturday, Sunday. Having promotions on hotter days will help conditions correlate with higher revenue. Adding targeted upselling programs would be beneficial for the business. So, having the staff being trained on suggesting bundles, knowing the promotions will be helping with upselling those items. In addition, having impulse items near the checkout that people will buy will be beneficial. Promoting add on deals will increase the average transaction value for a significant predictor of revenue. In addition, adjusting staffing and inventory will be beneficial so that if there's more flow on the weekends, you can have more people present, which helps stock shelves faster, helps lines get faster so people can come in and out, and have less staff during the weeks where there's not a lot of consistent flow or less flow will be beneficial to add more of the staff on higher volume days than less volume days. In addition, displays. Displays are beneficial for stores offering cold drinks, summer bundles, or outdoor displays will have people wanting to buy them, having an eye, catching their eye, having more popular items by the registers. So when people are waiting, they can go grab it. So during hot days, if there's more customers and it's right there in the line, they'll buy it, which increases more revenue. For the expected business value, there's revenue growth, which means that leveraging promotions during peak periods could boost weekend revenue by 10 to 20% based on visual uplift patterns. For customer service, better staff allocation ensures shorter lines and higher satisfaction. So people will want to come in and out because they know that'll be easier with not waiting in line for a long time and having great people check them out with customer service with friendly staff is so beneficial for the store. In addition, cost optimization is beneficial, so shifting labor to weekend peaks reduces underutilized hours midweek. For the next steps, will be beneficial for the business is to expand the data set. So having holiday data, which means that getting data during the holidays or different seasons to see any differences in the trends. If there's marketing involved, you can understand the influence of social media and how that influenced more customer flow, if that was beneficial or not beneficial. The business should evaluate quarterly. So this helps the business evolve as patterns may change and operate more efficiently. Conducting weekly forecasting will benefit for resource management, time decision making, minimize risks, and improve cash flow management and alignment. This helps employees work together and be on the same page. So, in conclusion, from our presentation, the key takeaways are promotions significantly increase revenue, temperature influences customer flow, offering a predictable advantage on warm days, clear weekly seasonality supports advancing scheduling and forecasting. The store can increase in sales with targeted promotions. The strongest drivers of revenue are daily customers and average transaction values. Lessons learned from this presentation is that descriptive analysis forecasting produces an explanation and actionable prediction, and data helps improve strategic decision making. So thank you so much for listening to our presentation. We hope it provides valuable insight into how effective decision making influences business outcomes.